Hi, welcome to Pletronics. We're giving a quick look at a GPS module built here at Pletronics. What you're looking at here is a GPS module you see in the smaller board. The larger board is a test board we supply so customers can do various testing in their labs to make sure it works in their application or whatever application they want to use it for. The device features a 1 pulse per second input, and you can see we're locked to the 1 pulse per second currently by the flashing red light. The frequency timing source on this device consists of one of Pletronics' OEXOs. This is a very high-end TCXO capable of doing better than 0.28 part per million minus 40 to 85. One of the advantages of the module being built here is using our own high-end TCXO technology. In general, it can compete with some low-end ovens with a fraction of the power requirements. The TCXO requires about 3 milliamps, and OCXO would require at least 100 milliamps in the same application. As you can see, we've got a number of options on the board for different power supplies and testing. You can jump out the 1 pulse per second for internal or external and different frequency sources. What we're looking at here is some of the outputs for the GPS module from Pletronics. What you're looking at is frequency stability currently. We're viewing this through TimeLab and a Hewlett-Packard frequency counter. One of the advantages of looking at this methodology is we get a good sense of the stability for measurement, and we can switch around to different test methodologies, taking a quick look at the Allen deviation while the device is running. A lot of customers inquire about the performance of Allen deviation on these devices. Some of that's determined by the frequency control source on the device. This is a good way of characterizing the device. This is another test and measurement look at the GypSync module by Pletronics. What we're looking at is 1 pulse per second. The upper 1 pulse per second picture is a reference coming in from a GPS source. The 1 pulse per second on the lower picture is what is coming out of our GPS module. A number of things will control the stability of that, but the 1 pulse per second and the frequency stability and the holdover are key criteria people use to decide what type of a GPS module do I need, what stabilities, what holdovers. The holdovers in general are related to the grade of the frequency controlled device. When you want very, very tight holdovers in the microsecond realm, typically you're into high-end OCXOs.